12th Maths Chapter 2 Complex Numbers Exercise 2.5 Question number 8. If the area of the triangle formed by the vertices Z, IZ and Z plus IZ is 50 square units, find the value of modulus Z. See, the triangle formed by the three vertices, the coordinate is Z, IZ. So Z is an arbitrary point. Let me take on the first quadrant Z. How do you get IZ? Just multiplying Z with I. That means geometrical meaning is we are giving the rotation of Z in 90 degree. 90 degree. So it takes the position here IZ. IZ. And also the third vertex is sum of these two complex numbers Z plus IZ. Actually, if you add, you can take some number 2 plus 3i and so on. Just you see that the sum of these two complex numbers, either they lie in this first quadrant or in the second quadrant, because we have taken the Z in the first and this IZ value is in the second quadrant. So let me take here, this is Z plus IZ. Z plus IZ, it coordinates. So this is A and B. See, actually Z is, we say that X plus IY. X plus IY. So X is real value, Y is imaginary value. So from the X axis, you will get this is Y, and then from the Y axis, you will get the X value. And what about the line joining this origin? You will get the x squared plus y squared. This is x, 90 degree. So root of x squared plus y squared you will get. Root of x squared plus y squared, that is your modulus z. So this modulus z lies here actually. Again you join here for IZ also the same modulus z. So what do you say about B, BC and this AC? So let me find this BC, AC. So this is 90 degrees, so this should be 90 degree because four-sided figure quadrilateral. So one angle is 90, so opposite angle is here is a 90 degree here. So let me find first BC. BC is distance between IZ and this. IZ minus Z plus IZ. So IZ minus Z minus IZ. So IZ cancel modulus Z. This is your BC. And what about AC? AC is equal to modulus of here Z coordinate minus then Z plus IZ. Z. So Z minus Z minus IZ. That is Z cancel modulus of my minus IZ. See modulus I is 1. So modulus this is plus. Therefore you will get again modulus Z. So this side also modulus Z and this side also modulus Z. So two sides you got. So you can find the third side also. That is your AB. So AB is equal to AZ minus IZ. Here IZ. See, this BC is modulus Z and AC is modulus Z. It is an isosceles right angle triangle. So the formula is half into base into height. So what is here? Half square units you can take. So half, what is base here? The adjacent sides of this 90 degree. You can take one as base, the other one as height. So half modulus Z. And they given that the area is 50 square units. So you write this is equal to 50. So modulus z squared is equal to 100. Take 2 to the other side. So modulus z is root of 100, that is equal to 10. So this is the answer. Modulus z is equal to 10. See the ninth sum. See ninth sum. Show that the equation z cube plus 2z bar equal to 0 has 5 solutions. The equation given for us is z cube 2z bar is equal to 0. So in this equation, as it is, we cannot take any common elements here. This is z value is z bar. So what I do, I take this minus 2z bar, minus 2z bar. So taking modulus on both sides, so modulus z cube is equal to modulus minus z bar. Actually, modulus z bar is same as modulus z. Modulus z bar is same as modulus z. So I write modulus z. Now you bring this to the left side. Modulus z cube minus modulus 2. See, and also one more concept. Modulus of minus is also plus. If you consider in the modulus, you can have this. So just it is 2z. So write minus 2z is equal to 0. Taking one modulus z outside, so you will get modulus z square minus 2 is equal to 0. So modulus z square, modulus z square, we can write it as z bar minus 2 is equal to 0. So either this modulus z equal to 0 or this z bar minus 2 is equal to 0. So see, I take this z bar is 1 by z, minus 2 is equal to 0. So z is equal to, take this 2 to the other side, this 1 by z goes to the other side. Z is equal to, z bar. One small correction here. Just keep this as z bar itself. Z bar. So z bar equal to, take minus 2 to the other side. So you will get here. See here, z bar minus 2 equal to 0. So z bar minus 2 0. Take 2 to the other side. From this, z bar equal to 2 by z. You substitute this z bar equal to 2 by z in this equation. Actually, original equation z cube plus 2z bar. So let me substitute that. So therefore, take z as LCM, z power 4 plus 2, cross multiply, z vanish. So z bar plus 2 equal to 0. So this equation has equation of degree 4. So it has 4 roots, and also we have modulus z equal to 0 here. Z equal to 0. So one root you have here. Therefore altogether 4 plus 1, 5 roots. Next is 10. See the 10th sum. Find the square roots of, first sum 4 plus 3i. Second one minus 6 plus 8y. Third one minus 5 minus 12i. Let me take a complex number z as x plus ib. I am going to find the square root of this a plus ib. See, directly you can apply the formula. This is equal to plus or minus square root of modulus z plus a by 2. This is your real part, plus I b by modulus b. Square root of modulus z minus a by 2. This is the answer, where b not equal to 0. And one more condition, if b is positive, you will get this one. If b is negative, just write b is positive, modulus b is equal to plus. B is negative, b by modulus b you have to substitute as negative, minus sign. That you must be remember. Okay, first sum root of 4 plus 3i. This is equal to, here A is 4, B is 3. Just replace and substitute here. So modulus Z plus or minus modulus Z. What is modulus Z? Root of 4 square plus 3 square. 16 plus 9, 25. So you will get 5. Plus A value is here real part 4 by 2. Plus I into B by modulus B. So what is the value of here B? If B by modulus B if we have, just you can write plus. So no need of substitute the values because this B get cancelled. Only we concentrate on positive sign. And then root of modulus Z 5 minus 4A by 2. Simplify this, plus or minus root of 5 plus 4 is here for you 9. So root of 9 is here 3. 3 by root 2. Root for 2 plus I into 5 minus 1. Root of 1 is 1 by root 2. This is the answer. For the second sum, root of minus 6 plus 8i. So A is minus 6, B is 8. So this is equal to plus or minus root of modulus Z. Modulus Z is 6 squared plus 8 squared. 36 plus 64, 100. That is equal to 10. 10 plus A is minus 6 divided by 2. Then B is plus sign. So just write for B by modulus B, you write positive sign. Then modulus square root of here. So just only for this. Square root of 10 plus A plus 6 by 2. This is I. So root plus or minus 10 minus 4 is 4. Square root of 4 is 2. 2 by root 2 plus I into root 16. Root 16 is 4 by root 2. This is equal to plus or minus 2 I can replace as root 2 into root 2. So 1 root 2 gets cancelled. 2 plus 4 I can write it as 4 as 2 into 2. 2 into root 2 into root 2. 1 root 2 gets cancelled. So plus I 2 root 2. This is the answer. Just remember the formula, that's all. Third sum, root of minus 5 minus 12i. This is equal to plus or minus root of modulus Z. Modulus Z is 24, 5 square 25, 12 square 144, 169. Root of 169, 13. Then A is minus 5. Minus 5, B is minus 12. So minus 5 by 2. And see here, in the formula B by minus B negative means you will get the minus sign here. So minus I into root of, again modulus Z, that is 13. Then A minus A, but A is minus 5, so this is plus 5 by 2. So plus or minus 13 minus 5 is 8. 8 root 8 by root 2 minus I into root of 18 by root 2. So plus or minus, they are under the same radical sign, just you can cancel. 8 into it goes 4 times minus I into root 9. Plus or minus root of 4 is 2 minus I 3. That is 3i. This is the answer. With that, this exercise problems are over. Thank you. Just you go through and be thorough with the formula. Modulus Z plus A by 2. Modulus Z minus A by 2. B plus modulus B is just we need for only to determine the side. No need of substitute the values. Thank you.